This is my AP Stats final project. The initial idea started when I was sitting in class and Mr. Kelly, who is my AP Stats teacher, turns to the kid next to me and says, "You've been gone from class for almost 17 minutes. Where have you been?" And so naturally, I'm curious, where has this kid been? And so I talked to him a tiny bit, and I realized that there is an ongoing trend within Mr. Kelly's classes and within other classes that students go to the bathroom for way above the time that the teacher expects. And so for this study, the objective was to look at the entire population of students who are enrolled in one of Mr. Kelly's classes, and to look at their time spent in the restroom during class as compared to Mr. Kelly's expectation. And so I will be performing a one sample t-test comparing the population mean to Mr. Kelly's expectation mean. And the survey itself was conducted by placing a sheet of paper with a grid in class, and every single time a student had left class for the bathroom, Mr. Kelly would essentially force that student to sign this piece of paper with the amount of time that they were gone. Now, yes, there are issues with this, and there are biases that exist with this. The first one that I came to is, yeah, people are gonna go to the less time to the bathroom if they know the teacher is specifically looking at them, and so you could call this a response bias. That said, I understand it, and I continued with my survey. Another bias that could have happened in this survey, in the study, was that the distribution wasn't necessarily normal, as we'll see in a second. Right over, this is the survey that what it looked like in class. This is the raw data, and oh no. This is what the distribution of times looked like. And so yeah, it wasn't necessarily normal, and I understand that, and yes, there might be a point of bias here. I continued with the study regardless. And so if we scroll up for a bit, we see here this is a computer software called Stat Plus Mac. You see right here. So yes, there were 34 people who wrote their names with a mean of 4.67. Now, right off the bat, Mr. Kelly told me I expect students to be in class for to leave class for the bathroom for a maximum of 3 minutes. So that was my expected my expected mean. Whereas we see here that the sample mean that we see right here, it's 4.67. So right off the bat, something is a bit fishy. It's not, doesn't sound exactly like it should be. And so we're gonna scroll down and do our t-test real quick. Right here you can see the box plot of all the sample data, and so you see that the solid blue line is the median, and the dotted blue line is the 4.67 that we were talking about, the sample mean. You also see that there's some really weird influential points out here, one at 12 it seems, and one at 17. And so these two students were way beyond the gates of the normal distribution, you could call it. And so now we're going to perform our actual test. And so first of all, this is what a t-test looks like. I'm just going to explain what it is. This is sample mean, so it's the mean of all of our samples minus the expected. So the expected is the null hypothesis, which we see right here is 3, divided by the standard error. Now we're using standard error because we don't know the sample deviation, the population standard deviation. We don't know the real one, and we only know S. We don't know what sigma is. And so we're going to be using this formula here, where it's S divided by the square root of n, rather than sigma divided by the square root of n. Looking real quickly at our null hypothesis and our alternative, we set the alpha level, sorry, before we even start, we set it at 0.05 because that sounds pretty reasonable. We say that our expected is 3 and that anything else is above 3. Why? Because Mr. Kelly said that he expects people to be at 3 or less. And so at 3 would be the cutoff point. Anything greater than 3 would be the observed. And so here's all our variables, and being our counts. This is our 4.67 that we were talking about before with the sample mean. S was calculated up here as well. Where is it? Right here. It's right here. Standard deviation. And then we're gonna do the mathematics, the algebra. What we're doing here is we're finding a p-value, a t-value, a t. Once we do that, we're going to plug that into our calculator, and we're gonna find that the final p-value is 0.0014. So what does that actually mean? If we interpret it, it says that there is a 14% chance, or 0.00414 p-value, of suggesting that if the null hypothesis is true, so we're saying if people do actually show up in 3 minutes or less, then the probability of seeing a sample just in general data above 3 is 0.0014, so 0.14%, sorry. And so that's extremely small. It's beyond infinitely small. And so we're instantly going to reject the null hypothesis, which gives sufficient evidence to suggest that students in his class go to the bathroom above the 3 minutes that Mr. Kelly suggested. Obviously, you cannot support the alternative hypothesis, and so we're just giving evidence against the null. Here I talk a tiny bit about my conditions again, which I did earlier. And then there's a grand conclusion, which is numbers don't lie, basically. Obviously, the students in Mr. Kelly's classroom go for way more than 3 minutes. And so either he needs to change his strategy towards students going to the bathroom, or students just need to get their act together and basically stay more in class, because class is important. And yeah, that's my overall findings of my AP Stats project. Thank you for listening. That's it. Thank you.